Hey everyone, this is a quick video on how to use the ANSYS Workbench. Just a quick little introduction on ANSYS Workbench. This is to help with your junior design project. Now, usually we use ANSYS APDL, and it's nice, but the main drawback, in my opinion, is the user interface. With ANSYS Workbench, you can undo things, delete things. You can see everything very clearly. You can look at all sorts of aspects of your mesh, of your simulation. So I think it's a little better software than APDL. Although the user interface seems a lot better in ANSYS Workbench, it should be noted that ANSYS APDL tends to be more accurate for more complex assembly, and the user has more control over what the program is doing. In ANSYS Workbench, the program is doing a lot of stuff for you and maybe making incorrect assumptions. In ANSYS APDL, you have control over everything. It's like writing MATLAB code. You can write your own code and have the software solve that. So although the Workbench interface is great, it's also highly recommended to become familiar with ANSYS APDL as well, because it does tend to produce better results for more complex assemblies. So to access it, once you're on the CAE workstation, you can just right down here, ANSYS Workbench. That's what you want to open. And with Workbench, you can do all sorts of simulations. You can do fluid simulations, electromagnetic simulations. But what you'll probably have to do for your junior design project is a static structural simulation. And the way you do that is you go down here, static structural, just drag it in. Okay, so now let's define our material. Usually by default you get structured steel, but I will just make up a material. It will be the one that we usually use. Okay, so you have all sorts of properties over here, but I'm just gonna go and give it a classic isotropic elasticity. Over here you can change the units, PSI, 2.9 e to the 7, and then for Young's modulus, 0.3. Alright, so just once you're done, X out of it. For geometry, I will just import geometry. Okay, so now we can model the simulation. Alright, so we have the beam that we used, and this is, make sure this is in inches and pound mass and pound feet, US units. And first thing I'll do is assign the material. So under materials, my materials, create material assignment, select, go into body selector, select this body, apply. Okay, so next we can just make a mesh. Let's see what kind of mesh. This is automatic. Okay, so this is a very coarse mesh. My guess is we'll probably have to do a convergence, but I think we should get decent results with this anyways. Alright, so next, let's apply the pressure. Okay, here. So static structural, insert pressure. This face, apply. I believe it's 10,000. 1, 2, 3. Okay. Oh, minus 10,000. Okay. Next up, we can go back here, insert, fix support, click on this face, apply. This is like doing 0 DOF in ANSYS APDL. Okay, so I think we're all set now. We can just click solve. Alright, and under solution, insert total deformation, insert stress, von Mies. Let's retrieve those. Alright, total deformation, we get 00069 equivalent stress 10.5 KSI. So over here it's roughly the same. Look at DOF, displacement vector. Yeah, 007. Okay. Now keep in mind this one was done with with smart size mesh 1, so it has a much finer mesh. And we can actually have this ANSYS Workbench do convergence automatically. So in equivalent stress, insert, down here, convergence. 5%. You probably want to do usually 5%. Otherwise, it might never converge, or it might converge too early. And yeah, we can solve this. See what it does. Okay. Alright. Let's try. Okay. You can see the mesh is getting really fine now. Okay, so around 11,000. Yeah. And we around 11,000 here as well. So that's how you use ANSYS APDL. Total deformation around 007 as well. The interface is much nicer. We can also look at, if I go to mesh, metrics. Yeah, it's most of these elements are not too good. But a finer mesh would fix that. And you can also do things like map meshing to have really nice elements. But yeah, this is just a quick ANSYS Workbench tutorial. You can also do 2D analysis if you wanted to. Yeah, you can do 2D analysis if you wanted to. But yeah, this is ANSYS Workbench. I think it's very useful for the junior design project. Just make sure you pick something simple, something that pertains closely to the course, whether it be fluid mechanics, vibrations, maybe thermodynamics, heat transfer, something like that, something not too complicated. But yeah, good luck with junior design project, and have a good winter break.